Welcome back. I'm going to continue on where I left off, focusing on setting the matches to being greedy or to matching in a greedy or non-greedy way, meaning that they find the first match or larger spans, and then also to be able to pull out and look at and or save what those matches are. First thing, if you saw the last episode, since I noticed what happened, I'll go ahead and point it out. When I had tried to look at replacing anything that was not a white space, I had, let's see, I'm going to run just this, and notice it replaced nothing. And I wanted to point this out because I noticed this before and then I forgot it in the moment, that the not caret only works within the square brackets. So you can use the not with the predefined character classes, but they have to be within the square brackets. So running it with that, it replaces every single thing that is not with, in this case I had used S. So carrying on from last time as well, I also want to show one useful way of replacing that's not character classes, but I think is enough related to go ahead and show. So what was I going to do? Oh, I need to define another text, and I'll call this a name text. And with this one, this is the first sentence with John. So say, for example, I'm looking at a text and I want to take out people's names. This didn't seem to work with character classes, and maybe I'll show that with the character class first, since I tried it that way and found out that it didn't work. So if I tried with John or Mary, you can probably already see why this isn't going to work. Suppose I wanted to make it anonymous, so no one's actual names would appear, but the people would know that there was a name there. I might do this, name text, and of course I want it to be compatible with Perl. What happened is it replaced anything with J, O, H, and N, and M, A, R, and Y, which, oh, I didn't run name text. Always something, which isn't actually what I wanted to do. So suppose I don't know all the names, because there's so many different names, it's actually very difficult to make a character class with the names. The alternative is to make it an expression that it will look for. So it'll look for these together or these together. So suppose I were looking through and I saw that John was a name in the document and Mary was a name in the document, and I wanted to replace every single time it found those, then I might do it this way. So moving on to the main point that I was going to talk about here were matching expressions. So if you're following along again with Gries, he is talking about this on page 86. And I'll start off with putting the first, I can't type and talk at the same time, so I'll put this in here. Just the first text. All right, and I'm going to save it as the match. So in text, notice there's several places that would match with S. This is anything between, and this is one or more occurrences of whatever character it is. So this could be a match here. It could be a match all the way to here, or a match all the way to here, or a match to here. So if we run this, and then I run the match, the only one that it actually found starts at position 4, which is here, and goes all the way to 22, which I believe is to right here. But if we want to see that and have it pull it out, that's actually the second thing that we're going to do. So let's see, how do I want to do this? So to pull out from a string, this is the text that we want to pull it from, and we need to find the start. So whatever it is, I'm going to call it the start, and then we need to find the start location, and then we need the end location. So I'm going to come back up here and start working to find the start location and the end location. So the start location, we can get that by unlisting from gregexpr. So it unlists this right here, which gives us just the start position. So we could unlist all of this together, but it's just easier to see since I already saved it. And if we want to see it, show. There we go. So it's 4. So then we also need to know the end location. And to find that, we need the start. I could use match start, but I'm just going to use this all together since it's similar to how he did it, even though he didn't save the start and the end together. So the start, and then use attributes to find the match length and let me go ahead and finish this up. But I think it's worthwhile to look at this one too along the way so we can see what's happening. Okay, so if we find the attributes of the match, and it's a list, so it's the first thing in the list, so the attribute of match length, it's 22, and so that's what it's pulling out. So it's finding the start position, and since we don't want it to double up where it started, or where it connects the start and the length, then we subtract 1 from it here. So that gives us match end, and just so that we can see that, that gives us from the beginning all the way to 25. So then it's position 25. This will pull us out of the text, start position, end position, and this was the match. That would be considered a greedy match because it didn't stop at the first one, it didn't stop at the second one, it actually went all the way to the longest one. And that's what we can change. So to use the same example that he is using, we'll make ourselves some corpus line, and it'll have just one character string. He said, you are lazy and you are stupid. Oh, that's not very nice. And then we'll use gregexpr to look for you. Anything that occurs any number of times are some corpus line, and we want it to work in Perl. So we'll run that. We'll run that. Notice UR actually occurred twice, but it's doing a greedy match, so it started at position 10 and 24. So if we want to see that, I'm going to take just the, do I want to do that one, the match. Suppose I want to be able to visualize and see what it's pulling out. Instead of text in this one, I'm going to do some corpus line, and then everything let's see. So if I want to do out of some corpus line, the match start was just unlisting the match, and then the end should be that one. Let's see. Oh, we already did that one. We found the match. And so this was all the way from, interesting, noticing that it started from he said, and it's unlink. I haven't used unlink before. When I use the right one on list, it starts with said. It should start with you. Well, there's always something when I copy too much. So I copied the S and S, and I actually want it to be still finding the match for this one. Let's try that in. There we go. So it went all the way from you are lazy to you are. So to set all the quantifiers, I'm going to start with, actually, I'll copy all of these so that we can see it each time that we run it. To set all the quantifiers, he identifies $u, and when I tried to look this up, I couldn't find very much about it, but I could see how it was working. So it seems to set all the quantifiers to finding the first match, or finding all the matches rather than the longest, greediest match. So let's run this one. It finds a match starting at position 10 and starting at position 27. Actually, this is not going to work now that there's two. Let's see, so I will need to, oh, I don't need to be running this twice is what I don't need to be doing. Oh well, I'll go ahead and put it in here, and then I need to be finding, if I want to be able to see what it's finding, I'll do this one at a time. So it'll find the first one, and the first one, and then the attribute of the first one. Let's try that. I didn't run this one. There we go. So we have, oh, since we didn't do anything after it, I'll change that in a minute so that we can see it. But if I want to see the second one, then this should unlist the second one, the second one, and the second one. And it's hard to see because they're both UR. So a way to be able to see that is to say that we're also going to look for a space, and we're also going to look for, oops, a couple of these, to look for anything that's a character after it. And when I tried this first, I put a plus because I wanted to look for two or look for one or more characters to see what word would come after it. Like I wanted to see what collocated. And it was interesting to see that you couldn't see the full word. And I realized that it was because I'd set it up as all the expressions, it was non-greedy matching because of this. So if we want to see how to be greedy only in some cases and not in others, is we can put the question mark after here so that we can say only one of those, and then here it'll continue to find more matches. I don't need to keep copying that one. So if we run this one, and this one, then we could see that it found the full word that came after you are. Let's look at one final thing. Going back to the text, I'm going to, which one do I want to copy? I'll come to this one. So before we looked at this, and if we put in our question mark here to limit it so it finds the first one, we can, or not just the first one, but it finds all of them. We can see that it found 2, and remember before we talked about it finding 3, which if we want to just really quick look, didn't find all 3 of them. Remember, we're just looking at the first one. Here's 1, here's 2, here's 3, and oops. If I want to find out what it pulled, I can take all of this. I could put it all into this substring, but since I put it into the match start, and wanted to look at what match start was, and then found what the attributes were for the match length, and then took one off of that and found, okay, that's the end. Although, no, actually, now that I'm thinking of it, there's 2 results, which is why I had done it this way. So we need the match, but instead of using some corpus line, we need text 1. And instead of using some corpus line, we need text 1. Okay, so there we have it as the 2 that it found, so it didn't find the third one. And what it appears to be is when it finds the first one, it uses this one up, and let's see, so the second one that it finds is this one, so it finds this, uses them up, and then finds this. And that's where we'll end today.